only a few changes. I just want to catch them. So with that, this is sort of where we are, part 2. Last week I did the virtual object system level of the work. This week we're going to do what I sort of the enterprise edition, if you will. Major topics: garbage collection, assemblies, which is our deployment story, contexts, and remoting. And then, assuming the feedback is as positive to this as it was to last week, we will definitely schedule the next 2. One is on security, and one is the reverse session where we'd like to get feedback from research on, as polite or cruel as you choose to be. Cruel. Okay, whatever. What's wrong with the COM+ runtime? And I do have a commitment from our side that if we choose to do that, I will be able to get the decision makers and the key technical people here for the full hour and a half to hear the story, and then we will roll forward with discussions. I really would like to see that happen. But in order to make it happen, as an organization, Microsoft Research has to decide it's worth to do on an organizational basis, because you will have to get together, pull whatever you've got into an hour and a half presentation that gives the top few points. And we are in what I believe is a very good window of opportunity. People on our side are willing to listen, but the project is moving ahead at an unbelievable rate of speed. So we have to get the input soon, and we have to have it pre-prioritized for us so we get some idea of what you think are the most critical problems, where is the most bang for the buck, and then we can use that to figure out what we can do. But it has to be coordinated across all of research. We cannot afford to meet with individual groups or just hear a scattershot of 300 different problems. It really has to be organizational at that level. So that's as a challenge to you. There's also no way on earth that we're going to be doing this next week. I'm practically dead from having spent the entire week trying to put this presentation together, and I'm just not prepared to do it 1 week from today. And I also don't know what the schedule for the series is, so I'm talking at least 2 weeks from now. The same picture you saw last week, general overview. Last week we concentrated on the stuff down here primarily. This week we're moving up COM+ services and sort of the top level here. With one weirdo exception, I've decided to put in all the garbage collection, which is part of our how it scales story. And I've done the best I could about gathering actual numbers for you. And it's not as nice as I would have liked, but in the time allotted, we actually got some good information for you. Now, Patrick, where's Patrick? Patrick Sood, hiding back there, is Mr. Garbage Collector, and he's the Microsoft corporate garbage collector, if you will. So he's here to tackle the hard questions. Just wanted to make sure you all know who he is. He informed me when I talked about this last week that he has given 2 two-hour talks on this topic to Microsoft Research already. We have 15 minutes to cover this, so it ain't going to be anything like that depth. Okay, and it's going to go blindingly fast. So I apologize for those of you who wanted to dive deep on this one. You're welcome to schedule Patrick for another 2-hour session. So garbage collection, if you don't know what it is, it's basically doing lifetime of objects based on the reachability. So you start with some set of objects that you know must be available. You transitively follow the graph of things they point to and say, okay, all those things have to stay around. Anything I didn't get to, that's garbage, throw it away. And would you please, in the process, compact my space and make my memory more easily available and cache coherent, all those good, wonderful things. So here's sort of the thumbnail description of the garbage collector we use. It's a mark and compact collector, which means it walks through, marks all the objects in use, and then goes whomp and moves them down. You'll see a beautiful animated picture, courtesy of Mike Tutangi, of all that. We use a generational system which currently has 3 generations, 0, 1, and 2, and we use what are called write barriers, talk about that in a minute, to prevent writes into older generations that reference newer materials. We keep objects in order, and we compact, so that leads to low fragmentation, low memory overhead. It's an extremely cache-conscious algorithm. It's quite nice. There is no support for conservative garbage collection. It's what's called an exact garbage collector. And we do have, over Patrick's almost dead body, pinning support, which means that you can say this thing can't move for the short period of time. If you use it too much, your performance goes to hell. But used sparingly, it's in fact quite important. We believe we have, if not the, then one of the highest performing allocators on the planet. It's automatic memory management, so it's a state-of-the-art garbage collector right at its core. Uses this generational compacting algorithm. It has the property that the newest generation, which is sort of the most recently created stuff, is garbage collected most often. Good statistics tell us that almost all of that is, in fact, going to be garbage. Goes away very often. You rarely have to do more than that. When you do, you move it back a generation, and 2 generations, you get pretty much everything you need. Our goal, and I believe we've reached this, is that true, Patrick? For generation 0 collection, that's the most recent stuff, rarely more than a 1 millisecond pause. The maximum pause you get should be under 10 milliseconds. We haven't reached that. We need some operating system support, which we don't currently have, although it's been promised. If you take the total cost of memory management from allocation, computing the lifetime, and freeing, competitive or better than heap allocation with our best current allocator. For that, we're using the NT5, newest, fanciest, best heap allocator. And the goal is to make the collection process about as intrusive as a page fault. And people certainly accept that as a normally accepted penalty. For those of you who've seen some of these slides before, the new bullets down here is we've added something called allocation contexts, which are an idea from Peter Solich. I don't know if Peter's in the room, but we've implemented it. And the nice thing about these contexts is they mean that there's no locking at all in the allocation process, and there's no cache snooping in the average case, and in fact in the usual case. So these are the Mike Tutangi magic slides. You get to watch a garbage collection in action. So your new heap begins starting on a new generation of collection. As you proceed on, you have references to things that are still in use. Those things keep other things alive. You get a graph of those. As we go along, we preserve the things that are being referenced by these so-called roots, and we compact the referenced objects. We actually just move them down in memory as we go. And we merge them together into these generations. So generation 0, the end of the first garbage collection, there's nothing left in generation 0. It's all been moved back to generation 1. And we start allocating a new generation 0. And typically the garbage collection activity is all happening in here. Every once in a while we collect this, and we repeat the process. And every once in a while you'll go to a generation 2, which gets garbage collected even less often. So other generations, Patrick, do you have a?
Well, the maximum amount would be 10 milliseconds. The idea is that all generations accept the highest one of this size. So by fixing the size, you can ensure the quality of service. Then the last one is concerned with the technical aspect. Then we can move the
I'm just going to keep pressing the button and watching these slides roll by. It's fun. Okay. So there you go with generation 2. I don't know what happened in this slide with generation 1 vanished, but anyway. That's probably right. The other thing is we do dynamic tuning on these things, and we tune based partially on the cache size in the CPU, so that tunes directly to the machine you're on. We have acceptable fragmentation levels, and we have 2 different ways of collecting, having to do with whether we compact or not, having to do with what kind of fragmentation we're seeing. Yes?
How do you dynamically tune the cache size? Or would it be important to find the cache size?
I'm sorry, I didn't mean it quite that way. I mean, when you start up, you can find out what your cache size is, or you could know in advance, and then we tune to that. Write barriers. This is the classic problem with these generational collectors is you need some kind of barrier between these so that if new references appear, you can detect them and not throw away things that, if you're just looking at material here, you wouldn't realize that there's necessarily a reference to this. So you need some way of detecting somebody put in this old generation where you're not planning to look a reference to something that you might otherwise garbage collect. And that's what's called write barrier support. We're doing it today by actually a code generation of our jitter is actually when you do stores, it's generating a little more code to put those in. There's some tricks you can play with the operating system to make that much more efficient. And we have commitments to have that happen, but it hasn't actually materialized in product yet. This is a little bit about the dynamic tuning. So the goal was to decide when you need to garbage collect and exactly which technique to use. The goal is to make all of generation 0 fit in, I think you said, about half of the L2 cache, right? So the goal is to tune it so that your frequently collected stuff takes about half your L2 cache. That means the stuff's always sitting there, always ready to go, and you are not typically going out to the memory. I forgot what the constant growth model was. Remind me about that.
The idea is that we can estimate the rate of allocation by saying that if we do garbage collection, the rate of allocation is constant.
Right.
And so we compute it and then we update it so we can know when it is time next to garbage collect phase.
Right. Right. So you have a linear prediction of when the next GC ought to occur. And then it chooses a sweeping or compaction based on the amount of fragmentation that's tunable. I stole these right from Patrick. He's the one who should actually be saying this. And if he says we win because, that's just so typical Patrick. It's wonderful. The basic things that are contributing to this garbage collector being as effective as it is the ephemeral design, so that the generational notion of it, and the cache consciousness, making sure the generation 0 fits in the level 2 cache, and note just because of the nature of the algorithm, there's only one part of this algorithm that's anything like a random walk. Everything else is linear, which is just beautiful for caching behavior. It also respects the object placement so that things clump together, stay together, and again, your locality is improved. And it has a very low overhead, unlike my favorite garbage collector, which is the two-space copying collector. It doesn't require a redundant piece of the address space just for the garbage collection process. These are the numbers we did manage to put together. They're not as many numbers as I would have liked to see, but they give you, when you compare them to the printed slide, you'll see another one that I'm not going to show right now for comparison. This is our most recent collection numbers. So you have a little program. This is a real program. It does 10 million iterations through a loop, exactly as written here, allocating a class, initializing the object and its superclass, assigning to its fields, testing the values in both of those fields, and never actually throwing. So it does allocation, initialization of all fields, and then reads back the values of all those fields 10 million times. I don't, unfortunately, know the particular machine it was run on, but it's an x86, a Pentium something. And basically for a single-threaded application running on a uniprocessor, it takes us 44 cycles per iteration. I do not have comparison numbers. I can't tell you if you did this in VC or VJ what the comparative number would be. The point was to look across the different implementations. If you go to a multiprocessor with only one thread, the reason we pick these is we do different allocation algorithms. One of the nice things about the JIT is that it can pick at JIT time which of these to use. So for the single-threaded multiprocessor case, it took 50 cycles. And then for two threads, which I think would be constant pretty much regardless of the number of threads, it adds a little more overhead. You get up to 66. You can compare them to your own favorite allocation algorithms. Those are pretty good. Questions on garbage collection?
those numbers are an average of the total cycle.
Yes.
Yeah.
Yes, that's correct.
Any kind of sense on perhaps the need that estimators across boundaries, across generations?
It's application dependent. I'm almost sure that's what the answer. Patrick, you want to?
Yeah, there is also some tuning that takes care of it. You find out that you are top heavy and then there is lots of post-generation pointers. Then the tuning engine has the policy to actually promote eagerly sooner than it normally would in order to reduce the post-generation that actually bring noise. The problem is there is only one health table for all of the generations. So the generation 2 to generation 1 are noise for when you scan for the fall from 1 to 0. So, and that's it, we have only one card because it takes space. So the trade-off there is if you have a lot of a fairly large generation 1 and a lot of generation 4 from 2 to 1, then you have noise and it increases the overhead. So that noise is detected, and when it's above a certain threshold, essentially a ratio between generation 4 to 0 versus generation 4 to 1, then we promote generation 1, or we garbage collect generation 1 to promote the survivor, into 2 to reduce the cost of the first generation.
Other questions on the garbage collection? Moving on to the next major topic, which is context. What is a context? Well, a context is it's our generalization of the support needed for object isolation. And I'll slide in a moment to show you what I mean about that. But the goal is to allow multiple domains of operation with objects in them so that you can control the accesses that go across the contexts. Processes themselves are partitioned into context. All objects live within a context. Each thread at every moment in time is in a current context. The context itself is represented by an object so that you can find out what context you're in. You can find the properties of that context. Given security rules, you can change the properties of that context and so forth. Between contexts, there are policies that control what happens when you reference from one context to another, and that policy, when it is invoked on the transition point, has full access to the process stack on the call side, so we can walk your stack and see anything it chooses to do on that side. It knows, if it's a call, it knows what method you're calling and what parameters you're passing, or if it's a field, it knows what field you're trying to access. And it knows the destination object you're trying to reference and the class of that destination. So that's a fair amount of information that it can pull on to make its decision. Obviously, pulling on the full stack is going to take a while, so relatively few of our contexts actually use the full process stack as part of the decision process. So this is sort of the picture. You're running in context 1. You have a proxy with an object that's in some other context, and you try to reference across. Then you go through the boundary crossing. And some examples of the kinds of policies you can have are standard security checks, which are identity checks of any kind. Those can be ones that follow the stack, where they could just look at local information credentials that are on this side and pass them over to that side. Type identity, it is possible, in fact, it's fairly standard to have two contexts whose reason for existence is that the class is loaded here and the class is loaded here. While they may be, in some sense, the same class, they are kept distinct because there's configuration information. So a kind of policy that you have across here is one that knows that the class I'm referencing over here is the equivalent of the class I'm referencing over there, and knows how to do that mapping back and forth. Synchronization boundaries is another reason to have context. These might be free-threaded, these are not. Transaction boundaries, those are the kinds of things that contexts are used for. Some more examples of particular things. Application domains are the ones that I mentioned before. They'll come up again. The idea of an application domain is it's a place into which you load classes. And if I load the same class into this application, domain and into that application domain, I get distinct classes. There is no class identity across application domains. That's critical for our deployment and assembly story. There are cross-process contexts in which the object referencing is done by copy and copy out rather than sharing. And then there are cross-machine ones that are like that, except that the copies can be slow, and worse than that, the copies may fail. And so you have to deal with all of those issues. And then the last one, which is a critical one we come back to later, is the notion of what are called agile classes. Agile classes have the property that any instance of an agile class might as well be thought of, or should be thought of, as being simultaneously in all contexts within the process. So no matter which context you are in a single process, you can get to that object without crossing the context boundary. If you're going to another process, you're going to a machine, you still have the context crossing. But strings are the classic case of this. There's no context information in a string. You may always get a string. Strings are not mutable as a result of that. And the general picture looks something like this. So you have context 1 with an object in it. It has a proxy that goes to what's called the sink. The proxy basically forwards the information. The sink's job is to do policy enforcement. I think this is one of the few slides that changed. We added one point down there. So sink is responsible for the policy enforcement part. It's responsible for the control transfer. So if you're thinking of this as a procedure call, it's the thing that does the transfer of control to the other side. It's also responsible for the data transfer. And it's important to note, and it's the one that didn't make it to the slide you're seeing, but is on the printed copies, that these, where is that? I have the next page. Here we go. Right. That the marshalling is not necessary. If marshalling happens, the sink is responsible for doing the marshalling, but marshalling happens only as needed. So sinks are not necessarily marshalling points. And then the dispatcher, if you like, is sort of the anti-proxy. It's the thing that gets notified that somebody's trying to get in and turns whatever the sink produced into either a procedure call or a field reference or a field write, and then returns the answer back in the opposite direction. That's the context story. We'll be digging more into that when we get to both assemblies or remoting, but are there any questions of sort of that level of the context story? So assemblies are about the deployment problem. What is that problem? Well, it's a disaster right now. The problem is, in this slide, I think, I didn't write these slides, and I actually love this slide. It captures it just beautifully. So the whole deployment system we've got is extremely fragile. So I installed some new database modeling package, and now all my apps that use OIDB are broken, and no one has a clue what's wrong. I mean, it happens to me all the time. Guess why I haven't installed Office 2000? I haven't installed IE5. I don't know when I will. I will when all of my other friends have done it and told me it's safe, right? And then it won't work for me. That's just my cosmic karma. You can ask anybody who works with me. Put it on my machine, it breaks. Okay? PowerPoint won't run on my own machine. PSS doesn't know why. They've had the open problem for quite some time now. The whole system is very complex. Captured to this question: why do I have to understand registry GUI in order to figure out if my application is correctly installed? I mean, what is that stuff, right? The whole thing is opaque. What's going to break if I get rid of this directory? Man, I have paid that price a million times. I know I don't need that directory. Wipe it out. Oh, hell. Everything goes to pot, okay? Do I have everything that I'm going to need in order to run this app offline? Wonderful question. I do a lot of traveling. I used to do a lot of traveling. Real problem. What do I need to move it to a new machine? Can I move it to a new machine? And my favorite one here is, you're looking around your machine. You run out of space on the disk. You try to figure out how did this thing get here? Can I move it? Can I remove it? Who brought it here? When did they bring it here? Why? What happens if I take it away? All those things. That's the problem. If I had been doing this slide, I think I would have put quotes around the word solution there, but it's our next pass towards a solution. So the goal is to some serious degree of application isolation. New applications don't break old applications when new versions of components are installed. That is the grand goal. Part of the way we're doing that is if you have configuration rules for an application, they affect the behavior of all the components that are acting on the behalf of that location. And the way that all works is we make the sharing explicit. So if you are building an application out of pieces, you have to explicitly say which pieces you are using, and we'll get back to some more of the details about that. I think one of the other changes I think you'll see to the printed slides is we updated this one too. Yeah, simple registration model, don't. That's basically our model, is you don't register things. Things are self-describing, so there's no dependency on the registry. Instead, the application carries with it everything that's needed to understand both it and what it's going to depend on. And there's a runtime infrastructure to support that, so you've got a set of services to define things, package them, advertise them to others, manage them, monitor what components are going on, what's going in and out of your system, and things are, to an extent, self-repairing.
There's no registry. How does the system know what to do when I double-click on a text file?
I didn't say we get rid of the registry entirely. We get rid of the registry for this purpose. Yeah.
So last one sounds an awful like you guys just did run it.
There's some truth to that, but when you see the details, it's not centralized, which is either plus or minus, but what we've done is we've moved it into the assembly itself so that you can go to the assembly and you can delete all the pieces you like as long as you have one critical thing called the manifest. It will reconstitute itself if you're online. And you can't get at those bits unless you play some very, very dirty tricks that we provide no support for. They're not in separate files. There are no tools to modify the information that's needed to do that reconstituting. So that's the biggest difference. So when you get an application, you'll see in a second, you'll get a manifest. That manifest defines what you needed, and it can always be reconstituted, assuming you are online. Yeah.
So you're basically solving the DLL health problem with the conquest system, right? Now, I guess there's other parts of Microsoft solving the problem more generally.
I'm sorry. I apologize. I have a little list of things I meant to say at the beginning, and I blew it on this one. There are two. I'm actually cheating. These slides also reflect work of three other groups that we're working with very closely. You fingered one of them. Fusion, we are relying on and working with Fusion as a large part of this. There is some friction about how much who's doing, as you could imagine, and each side saying you're doing it wrong and you're not doing enough, but that's very clear. Also, of the other two groups, and I really need to acknowledge them, the Helix group basically is the vast majority of our remoting story, and Complex Services is really our overall enterprise story. So Complex Runtime is basically just the sort of piece in the middle, and we're doing a lot of stuff that has to do with tool integration languages and capturing these boundaries in languages so that it becomes easier for programming side, but the vast majority of the work is actually being done by other groups, and we're not living in a little box solving by ourselves. We don't think we are. So the building block of this whole thing is, with apologies to Tony, assemblies. Not Tony's assemblies, these are ours. What is an assembly? It's a collection of resources, and it's sort of loosely defined. There's classes, HTML files, resource, whatever is needed, that are built to work together. And I don't like the term, but a lot of people do. It's a logical DLL. It's the unit of deployment. And so the unit of deployment, unit of versioning, the unit for reuse. It's a private mapping from the logical resources to physical packaging. So from the outside, you simply refer to the whole assembly. Inside the assembly, there's a mapping that goes from the names outside people that have used to your own way of packaging it up. So the assembly is a self-contained unit with an external interface and an internal apparatus. It has a manifest. The manifest describes really two things. It's an explicit list of the public resources, the things that are not packaged inside it, the ones that it's getting to from the outside. Those are the two things. A list of things it is providing to the outside and a list of things it's depending on from the outside. That's precisely what the manifest is. And, these are sort of obvious candidates for making assemblies. What's the manifest? Yeah. Yes. Doesn't matter. The example we're going to give says it's basically all of a tree. But the packaging is part of the independent. But in some sense, if I hand you the manifest, that's all I needed to hand you. It may be stupid to do that, so I may package that with a bunch of other stuff, like everything you need, or I might package it with a few bits that know how to find the rest of the bits. But that's that isolation boundary. So, it's sort of not a clear answer, but so that the manifest defines both the policies that you want to enforce and the structure, the internal structure of the assembly. So the manifest is what's used from inside of an assembly to reference any external thing. You go through the manifest. It is also the place where you express your requirements for version binding so that you can control what happens when new versions of old components are installed. And it has a bunch of additional configuration information, and that's sort of extensible at will. The intent is that it's authored or omitted by the tools, and it can be edited by administrators, but it's kind of interesting. It actually lives inside DLLs as an extension of the metadata that we already provide. So it's actually wrapped inside. Yeah?
Like, for fixing a problem, it's not that it could go with any future version, but later on they find it couldn't, they can edit this and say it needs to be repeated.
That's correct. That's exactly right.
Modify the original manifest manifest into the, and then you have
That's on the next slide. Yeah. Right.
This does imply, though, that there is a single .dll at the root of any assembly.
No. You'll notice that it says it can be standalone also.
How can that be if it lives inside a .dll?
Well, it can live inside.
Oh,
It doesn't. It's not that it must live inside.
got it.
Okay. But we're perhaps too flexible on this point, but we are extremely flexible at this point in time on this stuff. Who knows when we ship product whether it will have all of this flexibility, but right now it does. As long as it's library is flexible. Okay, and as it says, the admin can configure it, but the original is retained as a safe mode. So there's, short of going in with bit tweezers, you can't change the original of the manifest. The other point here is, for real simple deployment, you don't actually need a manifest because we can actually look at, if you have a simple DLL, we can look at the metadata that's in there automatically, in there anyway for other reasons, and we will produce a trivial manifest for it that says, basically, all the public classes in there are available to the external world. And it doesn't have any external dependencies, or it has what it was compiled with dependencies.
So everything I install on my machine will have a manifest.
Yes.
And you're just saying that when I'm a developer, I don't need to create one, I can get a tool to do it.
Yes. You should assume you should tool it. In fact, you should demand that your tools do it.
I realize this is probably one of your upcoming talks, but you haven't mentioned security in the context of assemblies.
That's correct. It's one of the upcoming talks. I will talk only a tiny bit about security. It really is a full hour's topic, at least. So just to give you sort of the picture of what happens. So you develop your system, you decide to make an assembly, you produce the manifest. This is presumably made, for the most part, by your tools. Sometimes you may, if it's a complicated enough thing, you may have to do a special tool whose job is to make the manifest. But if it's a simple thing, if it's just compile and link it together in the usual way, then that's all happening automatically. When you deploy it, you just copy that darn thing over. And so I say with this illustration, it's sort of a directory tree, but there are other options as well. And then there's no explicit registration or setup. As soon as you try to start that thing up, it registers itself. and then it runs in an application domain. The application domain knows the manifest of the application, and because of the isolation given by this context boundary, everything inside there is constrained. If it tries to go outside of this domain, it's trapped and essentially forced to go through the manifest, as I'll show you on the next slide. Yeah.
One thing that I don't quite understand here is how you're actually finding these high values in the manifest physical things such as location-based HTML files.
There's a whole story which I don't have, which is part of the Fusion story about the global naming scheme around all of this. And I don't know, do you know that there's a, actually, is Susan here, or Craig? Yeah, oh, right, Marcus, what are we talking about? Yeah.
There's two basic modes to deployment. One is actually a relative name-based deployment of something in a directory, and then you put this in or something, find the other manifest to make it available that way. And then there's an explicit machine-wide assembly cache kind of thing, where these things actually indexed, so you can then find them via frequent subsidiaries. The second deployment version is more used for shared component systems.
Does that?
Yeah. So it's a case where it's not an app that you just copy to install, but it's something like MDAC, right? I don't run MDAC, so how's it going to install itself on first use?
Yeah, an application is really a dependency graph of assemblies. If you think about it, you start with a root assembly for, let's say, Office, and it depends on the Excel assembly, which depends on the MDAC assembly. And as the code runs, it asserts the name of these components that it's trying to use, and that falls in the assembly one by one. Either it can be all pre-installed, or it can download them from a central host server.
I can't install MDAC by just copying it, right? Because I need to register it, otherwise nothing will find it.
I can copy it into a relative directory under my Excel application directory, and then it'll just work without explicit registration. If I want to use the system-blast MDAC version, then I have to register it in not in the COM sense, right, in a broad sense. Make it known to the system.
To make it known to the system, yeah.
Can there be two system-blessed MDAC versions?
Yes.
Yes.
So if my app calls for a specific version, then it can get that one at the same time I'm running an application, which calls for the latest version.
Yes.
The system blast is really, if I don't specify anything, which one should I get? And then all the other versions are still around. There's still machine-wide available. But applications only get those when they explicitly say, I need this version, or there's policy that says this application should run with this version.
So the manifest
Exists.
So system blast, well, there can be multiple for other factors like language, for example. There's German and English
Sure.
version of assembly.
Right, that's a good example.
But in terms of version, there can be only one system blast version for a given kind of assembly.
I think this is
Well, but you have side by side of
system blast.
multiple versions, right? So,
Of course.
yeah.
All the others are not system blast, right?
Right.
They're not blessed.
So the system blessed is still a lot like today's local register.
The previous system blast?
Yes.
Yeah.
But you have a way of making applications use the RCD non-system blast.
Right.
And the expectation that most ISVs will just lock the application down and say, I don't want to take advantage of the new features and make quicker. No, I'm happy it's the way it works. So I'll just waste this space on my customer's machine.
But I've heard complaints from, let's say, people trying to host IaaS environments for two different customers about the fact that today they have to all run the same version of something.
Yeah, but this one says you don't.
Well, no, it says if you take an action, you can isolate it. But by default, you'll still get the same stuff.
It's the person who shipped you the application who has said whether or not they're picking a version. If they are, then it's automatic.
I know.
If they said use the system blessed one, and they get the system blessed one, and I would say that you could take bets around this company and get different answers from different groups about whether the default mode for developers is going to be take the system one or take the one I was built with. And it's a religious debate, and when we ship it, we'll know what the market decides.
Okay, I mean, you mentioned that we
we're also solving this problem where you say, well, I think I can get rid of this directory, and you delete all this stuff, but somebody else really does depend on it. What happens? How does it get?
The thing I haven't said yet, and I actually don't think it's particularly covered in the slides, is there is a Fusion is creating a special area that's not directly user accessible unless you are a super guru type, where they cache the information. So the manifests go there, the unmodifiable manifests are kept there, and unless you kill that, you can delete the originals, and the manifest still says where to go back and get the thing if you need it recreated.
But you care for offline, so like, are they going to install a shell hook so that when you delete it, at the very least says something like, you won't be able to run your laptop without
I don't know. I mean,
You can't really get to this. It's sort of like the...
No, he's saying
No.
if you
I'll go and
delete
delete
the
MDAC,
reference
and
from
the system may say, I don't need to whine to you because I'll just download it again next time I need it. But it won't do that if I'm not connected to the net.
Or the dependency graph of the assembly just kept...
yeah, but he's...
Right, but if you don't tell the user, then the problem still exists.
You do get a warning. But users normally would not browse in there. They would only see the top-level application. And...
which is exactly what Jim said he does do. You go around browsing around saying, I don't need this, I need some space.
But I don't browse around inside of the registry. He's saying the assembly cache will contain the ones that are actually actively in use, and I'm not going to have permissions to browse inside of there.
No, but you'll still delete the files.
No, well, actually, I don't know. Does the assembly cache include the code itself or just the manifests?
It includes both in the second deployment mode, in this shared system component mode, and the files are also under scrutiny. Right? The system owns the store, and you can't just go there.
Right.
Do we get 2 copies of everything, or only one?
Maybe 3.
One per app.
You can get as many as one per app as the apps.
I believe the one that's in the bin directory, but you guys have another copy of it someplace else, and you keep putting it back.
You are getting it from the cache. The cache is a place you can't remove it from. So I think the answer to that is no.
Well, my understanding is in order to go back and isolate an application, say, oh, I didn't mean for it to get the newest version, you have to have access to the install files of the application.
That's correct. Yes.
And at the point you go back and say, hey, I want the old ones, not the current one, it'll go get them from wherever the application is.
So you have to be online.
So if you're on the airplane when that happens, took the CD with you, you might not be able to do it.
Right. So
when we're close to manifest, you mentioned DLLs and you mentioned standalone manifests. Any other kind of archival format, like cabinet files or zip files?
The packaging is orthogonal. This is more logical application manifest.
Well, actually, it wasn't orthogonal because you applied directory structure.
No, we didn't. I said that as an example is directory structure.
So it can be taken as a CAD file, as a zip file. Potentially others, maybe stored in a database if you're bound with SAP. We're still working through the exact issues. Currently we're focusing on this being a logical model, and then having the logical to physical abstraction allows us to pretty much plug in any kind of storage mechanism, be it directory, be it in a CAD file or database service.
So the development story here is that you should always think of yourself as offering something as part of an assembly. It's not a standalone thing. It's part of an assembly. I mean, the only thing in the assembly, but you should think of yourself as working inside of an assembly. The assembly establishes at development time, when you're actually coding, a namespace that you're working in, and you can extend that by saying you want to import from other assemblies. And those at runtime are going to be mediated by that manifest that belongs with your assembly. So that's the development model we're talking about. A deployment time, as I say, could be as simple as copy a whole directory, and the manifest might not be required. It integrates with all the usual things you want to integrate with, and the sort of the grand goal here is you get on-demand, zero-impact installation. It just does the right thing. Haggle around the details of that story, but that's the goal. At runtime, the way this all works is that isolation boundary called the application domain, and it isolates entirely one application from another. And that's how we believe it's going to solve the DLL health problem, or at least, I'm not sure solving is quite the right word, but we'll have another version 2 years from now. Hope it won't be anywhere near as bad.
Avoiding it for the runtime.
Right. The assembly itself is a namespace, and it does the resolution. It is what plugs into any global naming schemes. Its whole job is to mediate the cross-application discussions. The manifest governs the policy that's going to be used there. And this was I think you asked before about side-by-side. Yes, absolutely, side-by-side is the expected net result of this.
When it can happen.
When it can happen. So this is one of those marvelous animated slides where I push the button and see what it does, because I don't remember what order things happen in. So this was about the resolution mechanism. So if you're in a particular module and you reference something inside yourself, it just goes through the regular mechanisms, nothing needed. It's all internal. That's just fine. If you're trying to go cross-module to a different module, the manifest mediates you're getting to another module, even within your own assembly. And if you need to get something outside your assembly, you go through the module to the manifest. The manifest redirects it to some assembly resolver that figures out where the other external assembly is. Goes into this cache that's on your machine, sealed away where you can't get at it, see if it's already got that thing. If not, it calls the download service to find it from wherever it is, bring it back to you. Okay. Updates the manifest so that we know where it is. And it brings it back to you. That's the general picture. And the important thing is that there is an assembly-to-assembly discussion there that's used for resolving all external references. And so there is both outbound and inbound control, and there is version binding control on both ends of the story here. Speaking of versioning, yes?
I just want to jump back a second to the side-by-side multiple versions. So if you've got, say, 6 assemblies, and they all specify that I want to use version 1.3 of a particular component, and they all have that particular component on there, okay, we may be getting rid of DLL hell, but aren't we also completely eliminating the advantage of a DLL, which is that all processes share the same code, the same memory space? Or
well, be careful about this. You will share in memory. First of all, in the cache, you will have only one copy of all those if they're in fact identical. So that's not a problem on disk. In memory, you will share them as you do today with DLLs in memory. There is a little tricky side note here, which is because they might be loaded in different application domains, while the physical image itself is shared, at class load time you build some other data structures that are the runtime representation of the classes. Those have to be distinct because you're insisting that the applications are distinct. So you pay that penalty. And perhaps worse, in a JITted environment, the code that is JITted out of the portable binaries may well differ in the different application environments. You may not be sharing that code, which is why we have a code caching thing, which I talked about briefly last week. I mean, it does get involved, and there is a problem there. So versioning happens at the assembly level, not at the class level. So you don't version particular classes; you version entire assemblies. That's a simplification to make this whole thing manageable. Is the only thing as an administrator you need to worry about is your assemblies. The whole business is editable by administrators, but the original one is kept immutably. And absolute rule, if you change any kind of policy there, you get a new manifest, and the original is still kept. And the typical policies we expect are use most recent, use a specified version, or use only and exactly the one that I was built with. There may be others added, but yeah.
By version, you mean version of the manifest?
Sorry, I meant version of the thing it refers to.
So if I do multiple edits to a manifest, what do I have? Do I have multiple manifests or just 2?
Multiple, as far as I know.
So you cannot pause if you continue to edit the manifest for Word, for example, especially a toolbar position or something like that. You keep having only one, but you could have multiple manifests for Word that is different toolbar. And the UI implications are unclear at this point, and how the user model would be. Another scenario is IE, for example, used as an AOL browser versus standalone. You might have different settings for each of them. But the underlying manifest, the underlying code is IE is the same as them.
But if I say through time, when I edit the manifest to fix something, right? Now, a half a year goes by and I realize I have to fix something else because my world has changed. What am I left with? The original manifest and one manifest? Or have I got three manifests because it keeps all versions that I make?
The current thinking is we have only one manifest and we lose the history.
Okay.
But you have two. You have the original, always have the original plus you have the current. So you have original plus current. Thank you.
Okay.
But with a versioning file system or something like that, we could think about getting more.
Question there and then there.
Yeah, when you say version, do you mean like 5.2 or how do you define simple version?
Well, that's what I was getting about. 5.2 is the standard versioning thing, but you can do a tighter versioning based on hash coding. So you can hash the hell out of the thing and say that's precisely what I meant, which is not version, it's them their bits. So I take a fingerprint of the bits.
Or greater than
Yeah.
Okay.
When you address a manifest, are you controlling what manifest the subsequent one contractually negotiates? For example, so you suppose you built on some DLL that ran on the C runtime library, and you wanted both of those to be the same.
I'm not following the scenario, but maybe you
So
are.
it's a case of A using B and B using C, and
Right.
they want to say which version of
Yeah, I'm very particular about C.
It's a question of policy of B. B might say, my clients don't get to control what my underlying version of C is going to be. Sort of concept of a protected or private class. Or B could say, I don't really care, let my caller modify my policy. So like public and modify. And that applies to policy, it applies to settings, it applies to other things. It will be exposed, they can be private.
This is sort of a marketing phrase here because it isn't really exact, but the goal is that if you manage to run it once, it'll either run forever or you'll know in advance that it's missing something or that something changed. And it can actually tell you what got changed that's going to make it not necessarily able to run. That's a real difference from today. So it actually has enough history guaranteed that it can tell you why it won't be able to run before it even attempts to do so.
Until you upgrade the OS.
Maybe until you upgrade the OS. I don't know. I mean, if you reformat the disk, you're going to be in trouble, right? Right. Yeah.
Jump back to what you said about hashing. You mentioned less than, greater than. So even with the hashing, you'll still be able to.
No, the hashing base, because I'm taking a fingerprint. I don't believe in these version number things. That's it. You can't fool me. You can't release 3 versions of 5.2 because I don't trust you.
So in that case, you couldn't have a manifest that says, I want this particular.
I want
or
fingerprint this.
Or anything later.
If you do it by fingerprint, you can't do the or later. That's correct. Fingerprints don't have a date timestamp on them. I suppose they could, but no.
Well, in addition, that information is there, and things like policy, and the assembly could allow that or not allow that, and all the combinations of them. Like static linking, effectively. Just if the thing you're statically linked to is not there, then you're in trouble. But you get exactly the difference.
What's the extensibility story here? So I buy IE, and then I buy some new widget that extends IE in some interesting way. Where does this get recorded? I mean, I don't want my new widget. In other words, I've extended IE or I've extended Word to buy add-on packages for Word. How is this being recorded somewhere? I mean, is the manifest for Word being changed? The manifest for IE being changed? Does this not make any sense?
I'm going to turn it over to you. I'm going to have my answer, but I want to hear what Marcus, who's the expert, has to say.
Yeah, it's the question of like the dynamic reference that you don't know it complies and what you're going to be using for the OLA scenario, or then the other is that's a little weak at this point on how exactly that's going to be measured. Probably not going to get all the robustness we need here. It's definitely not going to allow the manifest for IT or the host to be edited.
you're still going to allow an ActiveX control to appear on a page.
Yes.
So
the question would be
what wasn't in IE's manifest, right?
Yeah. One way of dealing with
Well, that
this, we
doesn't
haven't really thought it through, but you could have a configuration manifest that modifies IE, and that could express the version policy.
Somebody's going to want to get their system back. I mean, the prototypical thing is they say, back up my system. I want it back the way it was. If you're not recording it somewhere, you can't get it back. If there's not some kind of explicit policy, explicit way of dealing with this, you won't be able to get your system back. Something not quite as bad as DLL help, but a new version of it.
It's a good point. We haven't really thought about that. I'm not aware of that.
Yeah.
When you fingerprint, do you use the original? Do you use the manifest? And if so, which one do you use? The original or the modified one?
The fingerprint is done at development time, right?
Right, but if the developers modify the manifest of what they're using, do you fingerprint against the modified manifest or the original one that you got hidden somewhere?
The original one.
The original.
If you want to mix fingerprinting with version control, there is a commercial hash-based data sampling mechanism that may be usable.
Yes, I know. Yep.
Related to a previous question, if A and B both use C and there are different policies of how to use C, how do you resolve that?
There's no, that one doesn't, there's no problem with that, right? If A and B both use C, but they have different policies of what it means, what that means, it just means there's side-by-side Cs.
Well,
yeah.
What the picture A is of C, so you basically have C1 and C2 which are for all purposes incompatible.
Yes. Especially if they've got global states being modified, you're in trouble.
Yep. You'll probably get a load time error instead of a runtime crash or data corruption.
No, you could get...
Still value proposition here. We can't make it work, but at least you get a reasonable error message that tells you what...
You could simply get unexpected behavior. The C runtime has static data structures it uses, for example, to keep track of your current locale. So A sets the locale, calls something in B which it expects to be influenced by the locale, but B's got an isolated C runtime which doesn't look at, which didn't see A's changes.
The whole problem is with the shared static,
right?
Global static state, no question. We're not going to solve that problem.
One instance of a class with a certain name in a given application.
Can C have a policy that prohibits its side-by-sideness capability?
Actually, the default policy is that it is prohibited. Right. We won't load two versions of the same class in the same application.
The same application,
but
same process, yes, but not the same.
Yeah, it's if they assert mutually, if they assert different version of them, they're different.
No, even in the same process, there can be a problem. The set locale one is one example.
Yeah.
Right.
Any static structure.
Right. You expect them to be affected and they aren't,
right.
Or you don't expect them to be affected and they are.
They are.
Either way, you lose.
Right. You're screwed either way. That was the end of the assembly story. We're not doing so bad. I expected each of these to be about equal time, and we're just on time there. So this is just a reminder. This is what our context story looked like originally, with the object, the proxy going out, the sync, and then the anti-proxy called the dispatcher. This is the remoting version. We just expanded in more detail and one hell of a lot more code. The notion is that there's a thing we call the transparent proxy that really just forwards requests on to the real proxy, which is a heavyweight guy who knows all about how to remote things in lots of different ways, and that the services, complex services, have been slaving away for what, 3 versions now. So it's got a fair amount of good stuff in there. That forwards to a sync, standard sync. But it's the client-side sync. That job is, again, policy enforcement, data control, and data transfer and control transfer. It speaks out some kind of message channel that goes across the actual machine-to-machine boundary to the incoming message side, to the anti-sync, if you will. It's the receiving side of the sync that unformats from the message channel format into the standardized format that the anti-proxy or dispatcher took. So it's really the same story, just expanded in all of its details, and considerably more heavyweight than the one that you'd use within a process or across processes on a machine would be. it's basically, it says I've got a V table that's been modified to point off to the alternate entry points. That's all it is a replacement V table. And it's the lightest weight thing you could have. A little bit more about message syncs in this particular model. They give you the support for either request response, so bidirectional, one-way messaging, and also multicasting. And they're composable. So the idea about these syncs is they basically make a nice, if you're an electrical engineer, they're pipelines, right? Fan in, fan out, asynchronous, synchronous. And you layer them together just like you would. You can also optionally add stuff as you pass through them. So you can put object identity in. Not all transfers need to know the object identity. Sometimes you're copying by value. Sometimes you're copying by reference. So you can put that in. And sometimes you need to pass things like serious identity information for security purposes. And I'm being very loose about what I mean there. It can be anything from the identity of a principal and a handshake between the guys saying, yeah, I'm willing to accept your principles as mine, to some kind of stack crawl, and I'm going to send you verification that none of the rules that you care about were violated on the other side. So it's sort of an extensible mechanism there. And then you can optionally have a reply sync, so you can set up your reverse channel. As you go forward, you can set up the reverse channel for the answer to come back. And the basic thing that we're trying to do in this whole remoting model is move from an interface-only world to a world of objects. So COM has interfaces and a large number of basic data types, but languages like Smalltalk and VC and Java and Cool moved on to objects, which include interfaces, everything you had with interfaces. They've also got classes. Classes have methods. That's all sort of standard stuff that we saw before in COM. The two new things we have to deal with here in this world are what happens with the fields that are part of the object, and what happens, inheritance I didn't mention, but inheritance falls in here too. And a particularly thorny one is what do you do with statics? Statics are part of the class, not part of the instance, and that's not part of the COM model at all. Yeah?
So, kind of refer back to last two. You mentioned classes, fields, and properties being two different things. What quickly make a distinction?
I'm about to get to properties again, so yeah, just hold on. We'll get there. So the basic goal of the COM Plus remoting story is that the runtime generates proxies and stubs automatically. You just don't have to do that as a programmer. We take care of it for you. There's an auto everything flavor that runs through what we're trying to accomplish. And if you wanted to say at sort of the highest level, what is it we're trying to do? We're trying to say that one of the problems with COM was that it didn't have support all the way up through the tools and programming languages, so it was hard to use. And part of that hard to use is you had to do manually a bunch of stuff that should have been and could have been automated by tools if that had been possible. We really want to make that happen, and we really want it to integrate deeply into the languages, so it's just part of, and the way I like to say it is, writing distributed applications is no harder than writing programs. Doesn't necessarily mean it's easy, but up until now, they have been distinctly different beasts. You could be an excellent programmer, and you could not possibly write a distributed app, and we'd like to make that distinction, I wouldn't say vanish, but I would say let's make the gap go considerably smaller. And so some of the features for that are really extending the same idea we had in COM with the base data types to a richer set of remotable types, which is the common language subset, and Brad back there runs the group that's defining that. We use the metadata that I talked about last week. Since it's available at runtime and the objects are self-describing at runtime, you can use that to do the marshalling and so forth, so you don't have to provide additional information for that purpose. And we want objects to be able to be passed either by value or by reference. So here's your question about properties. Properties, we're using them the same way they are in COM, as I understand it. And the trick here is that users think of them as fields. We managed to get the language tools to treat properties as though they were fields, so the ease of dealing with a field, but behind the scenes it's actually a method, and we know how to remote methods. So it was a nice trick so the users can think about state as fields and not have to worry about these awful procedures they'd have to call. And behind the scenes, it's actually remoted because it's methods, and we know how to do method remoting now.
How do you remote call by reference?
That's a real good question. We don't know the answer to that one. There's a slightly worse one about call by reference with the type is being passed dynamically to you. We don't know how to do that one either.
You can do it, just not very efficiently.
Yes. Yes, thank you. We can do it, but not very efficiently, and we are actually actively working very hard on attacking the problem. There's no way it's going to be as efficient as other things, but you do what you can. And when we get to the programming model, that's, in my opinion, the core questions. He's always ahead of me, right? Okay. Events. Events are a one-way communication model, really. We have a loosely coupled events model, and the basic pictures is plumbing. So you go from the source to the destination through some sort of plumbing thing, and you can register saying I want to receive events, and you can fire events through the plumbing mechanism. And then events themselves, when they're fired, actually pass data, and we capture the kind of data as part of the signature on events. So our events have signatures. To an extent, they look like methods. In fact, they use delegates, and there's a whole story in there, but we don't have time for it today. But that's the basic picture. Yep.
What did you mean by loosely coupled, and are these things reliable?
Scott's the PM for this.
Yeah, actually, I looked at the slide and I missed the fact that there's loosely and tightly coupled. Loosely coupled is still under design. It's going to be based on the services it provides to be based on LCE in COM+1.0. Your question was about loosely.
Well, what does loosely coupled mean?
It means that I don't know who the source is and I don't care.
If you have a registration service you go through, is another way to say that.
You know somebody who can give you certain types of events, and you go to him and say, give me those types, and I don't care where they come from. That's the loose part. Okay. And then tightly coupled is when you know your source, and you want to go up to that person and say, give me your events.
And what was the second question?
The second question was, are these communications reliable?
Oh, right.
Presumably events can cross machine boundaries and things like that?
Oh, yeah. Remoting is the
what's the model then that I have that these can vanish when errors?
I'm going to propose my answer, and Scott can shoot me if I got it wrong. To me, that's what plumbing you chose to use is a good part of that answer. So if you use reliable plumbing, you get reliable delivery, and if you use shoot it once and forget, then if it gets there, that's great. So quality of service is part of the plumbing, and it's quality of service is supported. But I tried to abstract this and make it, sort of a one-liner here. There were about 5 more slides, and there's just no time to do it. So
he's correct. Quality of service is a choice you make when you sign up. Okay.
So this is the remoting programming model. Oh, this changed. This changed in an important way on the slides. The title changed. This is Jim's remoting programming model, and it's a thought experiment. So this is not the COM+ runtime remoting programming model. Absolutely not. This is Jim's thought experiment, and it is subject to change without notice. And there are lots of people who would like to throw lots of rocks at me for this one, and they're welcome to do that offline. So programmers should assume that all classes support remote instances. That's sort of the base picture here is, by default, things are remotable. The current object, you're in a method, you are part of an object. That object is local. You are where you are. Well, yeah, right. And that includes all inherited states. So not only are you here, but your class, your grand class, your grand-grand class. I don't know, we don't have words for those things, but you know what I mean. They're all in the current context. There's never a boundary crossing. It's all free. Field access to remote objects is remoted. This is contentious. There is a meeting hopefully tomorrow that will settle this particular point. But one side of that battle is if you go to a remote object for one of its fields, it just goes slowly, but you get it. Static access to remote fields, so any kind of static, classes or methods, you get a JIT time exception. It's not actually when you run the program, but it's when you JIT the program, you discover that can't be there. You can, as a high-level programming language, you do have the right to say, I'm going to be conservative and guarantee that doesn't happen by giving an error at compile time, but you would be doing a conservative choice. And the runtime's part of that is to say, if the compiler didn't give the warning or the error, we will at runtime. We will never remote static accesses. And the other thing to remember is that when you're talking about local and remote, and I think there was a minor change to this slide too, yeah. Recall that instances of Agile classes are available in all local contexts. So you can always get Agile instances in your local context. Now, if you have a remote Agile thing, it's different. If you have a local one, it's in your context. So Agile means there's no boundary crossing as long as it's local to you.
What are the requirements to be Agile?
I hate you. You're on my team, aren't you? Right. What are the requirements to be Agile? I asked that question. The answer is you can be Agile if it's always safe to not cross context to get to you. That didn't say a darn thing, did it? Right? That's absolutely the current definition. And since we are free to add new contexts and new reasons for context crossing, it better mean there's just nothing that's ever going to get in the way. And the classic example is read-only strings, because we don't have any read-only strings that anybody wants to get in the way of your getting at. And there is a lot of question as whether this is a useful concept to have, and this is part of the contentious issue. And I will stop there before my management kills me.
Jim, question?
Yes.
In the last slide about the remote object field access being remoted, is there some kind of is there a convenient workaround in case you want to make frequent accesses to a field that gets infrequently modified, so the changes get sent to you instead of you having to ask?
The best answer, I don't really know, and I'm thinking off the top of my head. My response is for that kind of thing, you ought to be using a property, and the method you use is sophisticated enough to do that notification. And that would deal with that case. I don't know, Chris, do you have a... What?
You mean an event, right?
I'm sorry?
Event, not... I thought a property was simply a field. So an event is something that you listen to.
So you meant that inside the access or there's caching going on inside the...
Right.
And basically set up an event that would notify...
Exactly. You would manifest the field as a property, and it would use an event in its implementation to cause the notification to come to you when it changed. And that would solve the problem. Whether it's the best, the most elegant, the most efficient, really good questions, I don't know. But that's the... If we stick with the model as it is, that would be the answer I would give to that.
Don't you need a local copy of the class for that? Because I've got code running on my own machine that knows about the remote object.
That is the class.
You want a remote object, but one for which the code also exists locally.
That's always the case in our model. There is always some local instance of the class that you have, otherwise you can't talk to it.
So not just the interface, but the actual code.
Well, a version of code that talks to it, which might be a proxy that refers out, and in this case it might not be just the standard proxy, it may be a clever proxy that you might have to code, or maybe the infrastructure creates for you under certain conditions. But that would sort of be the picture, yeah.
Can I build a replicated object?
Oh, hell, I don't know. You better be able to. Anybody want to take that one? No takers. I mean, yeah.
A related question. You mentioned earlier that things like proxies and stubs are all generated automatically. Was that all of them or some of them?
No, that's a really good question. It's really open. The goal is that they all are. I don't think that's an attainable goal. So we will set some set of things that we will make automatically, and we will almost certainly have some mechanism for you to provide an alternative of your choosing. So then my guess is that's going to be I don't see any other way it can happen.
So, for example, if you wanted your proxy code to implement replication or
you could
retries on faults or whatever else you
That's right.
want.
And a lot of that is available through the existing mechanism, and for that we would manifest it automatically. But there are obviously things we didn't do, and so there has to be an extension mechanism to get to them. And to be honest, that's a really good question for the Comm Plus Services team, because we really open it out to the boundary of saying, we'll get you to that transparent proxy, and then what's on the other side of it is really their work, and I'm really not an expert. Not that I'm an expert on this side either, but I'm really not an expert on that side. Other questions?
Will you be able to revisit Agile classes and even remote classes, and how the security restrictions are applied to access?
Will I today?
In the security talk, basically. I mean,
if Agile classes are still there when we do the security talk, I think it would be very valid for us to do that.
I'm trying to figure out cross-context access that also go through a security.
I understand. The last talk is going to be one doozy of a talk, right? Yeah. So this is the one this is my theory of a way it might look. So my idea here was you just define your class in your favorite programming language, and maybe there are publics or privates scattered through this or whatever. And then the way you use the remoting world is you just say, new me a matrix of these things, 10,000 by 10,000 long, and we automatically provide. You didn't have to write it. The array constructor, of course, is built into this language. What is built in by the runtime system is automatically for any remotable class, we provide overload constructors that take lots of different ways of remoting things. So this is one that I've invented off the top of my head called remoting to a host. And that's an overloaded thing we produce automatically. You don't have to say it. If you pass this extra parameter, which is known because of the type of this is a constructor for a runtime supplied remoting piece of infrastructure, and it wants the name of a machine. Then it goes and talks to that machine. Maybe there are other parameters to this remote host thing, saying like what protocol to use and all that kind of stuff. But it's all automatically generated. Neither the person who wrote this class nor the person who used this class had anything to do with writing this code. The only thing the user of the class has to do is say, well, I know I've got a class, therefore I know there's a constructor that knows how to do remoting, and it's called this way. Now, whether the tools will do this, who knows? This is me smoking stuff in my office, right? Then you initialize the matrix, and you call that matrix invert routine, and since it's notice I remoted to the supercomputer, because inverting these kind of matrices, can take a moment or two.
So that takes the 100 million complex numbers from the supercomputer and brings it to your machine to invert, right?
That's right.
And puts them back.
Then I want to start printing them out. Right? And here's the part that I consider thorny in the programming model as it stands. I'm talking about some data here. It wasn't an Agile class. It isn't me. Can I get to this? How slow is it? Those are what I consider to be the hard programming model questions. And we haven't quite dug down to this level to answer them yet. We're getting there.
Are you assuming that the code for this class already existed there, or are you pushing the code up as well?
Yes.
Okay.
Or A or B. I haven't figured that part out either. My own personal belief is that whenever you create the server side of something, we automatically manufacture an assembly that has the client-side metadata with markers saying what kind of automatic stub proxies to create. And the client, basically, when it asks for that assembly, always gets the client side of that. So it doesn't get the server implementation. The server implementation stays on the server side. That's my own personal belief of the way it ought to be. There's no buy-in for that I'm aware of. Not that I'm not pushing. Cross-process as opposed to cross-machine remoting, we basically rely on the underlying OS local procedure call. Some of us grew up calling that IPC, but apparently it's called LPC these days. You use a channel to send and receive your messages. Those channels use ports. The ports use shared memory. The shared memory, never mind. It's turtles all the way down. Right? Cross-machine remoting. This is the harder case. Here we have this simple object access protocol, SOAP. SOAP, I think, is really one of the fascinating pieces here, and I'm really cheating. This is well beyond the runtime story. This belongs to our partners over in services, but I think it's just a neat idea, so I just want to highlight it. So SOAP really is the COM plus remoting story over HTTP, and the goal here was outreach. We want to be able to get to everything on the planet. When we go to other planets there too. It's got to be simple enough that SOAP endpoints, the things you talk to, can be created using practically any technology you want, including scripts. So little Perl scripts, Python things, ad hoc, whatsitses. And so how do you do that? The goals, leverage the web. Having been formerly at the Web Consortium, I think that's a great idea. The goal of this project was to make SOAP work well with the current web infrastructure, work even better as we move forward to the next generation of HTTP, and at the same time introduce no security holes. That's a tad tricky. Really support this wide reach idea. And the goal, from a corporate point of view, is to lower the barriers to adopting this technology. We want to enable interop solutions in heterogeneous environments, and we want to include classic COM in that, but we also want to include whatever stuff is there on the other side. This is, I'm going to wave my W3C flag. This is what the whole idea was. So method invocation. Objects are represented by URLs. If you have well-known endpoints, you don't need an object request broker. All that messy stuff can be discarded if you choose to embed direct knowledge of where to go. If you don't, then you can use object request brokers. You can talk about them by URLs too. It all depends on what the URL is too. And the web infrastructure already provides forwarding, which is the primary thing that orbs need to operate. We also, right now, we dynamically create instances. They'll also be able to connect to existing instances, but the current model is it makes a new instance for you. The invocation is over standard HTTP using POST and GET, and we've done an extension called mPOST, which we're trying to give over to IETF for standardization. So that's sort of an extension that Microsoft has built. Am I wrong about that? You're looking very puzzled. Yeah. IETF, right? Marshalling is done using XML for interoperability. You can optionally pass an interface. You don't have to. You pass a method and parameters. So it's intended to be a very simple, very lightweight protocol. It can be really implemented in any number of ways. So that sort of covers the enterprise story. Some of the open issues that we know about. The activation story is just getting underway. That's going to be one of the thornier issues. So, as I said, SOAP right now says dynamic, create the object, but that isn't the only thing. So if the thing's already there running, how do you talk about it? How do you pass parameters when it's created? How do you do any kind of negotiation to make sure that the metadata for the class that you wanted on your side matches the metadata of the thing that's running on the server so that you get the equivalent of class loading semantics over a remote network link, all of that. The programming model, you saw, Jim's pipe dream there of a programming model, but we need a real one. Distributed security, I can give you the regular security story, but once we got that and everybody agrees on that, we've got to go distributed on it. Concurrent garbage collection, so we actually have work going on for that so that you can run your garbage collector in a separate thread while your programs are running, and we think we have a high-performance mechanism for doing that. Yeah.
Does that imply that if I have a multi-threaded program, what happens when I garbage collect? All threads stop?
Oh no. Well, for a brief period, for one part of the garbage collection, that's true. But for the vast majority of the answer is no. It's actually going while you're running. You are suspended for individual threads, suspended for short intervals, and then there's a period where the whole system synchronizes, but it's kept to a minimum. Have I got that right, Patrick?
So what is concurrent garbage collection then?
Actually, that is concurrent garbage collection that I just described.
Future is concurrent.
Yes.
So So right now, the system...
Right now, the system has those 10 millisecond pauses of all the threads.
I see. Okay, so...
Right.
Thank you.
And
pause you see where the pause is not the bounded.
Right. And then distributed garbage collection, which is a much harder problem. What do you do if you've got an object graph that spans across machines not in single clusters? And that's an open research topic. Yeah.
One of the other open research topics I've heard is bounded garbage collection. Don't take longer than X.
Yeah. I think if you talk to Patrick, I think we're actually fairly happy with where we sit on that particular one. So we do not do hard real-time. We don't meet hard real-time requirements, which is the bounded garbage collection. The risk of having Patrick get mad at me. The last attempt I knew of trying to do that wound up in a situation where they could promise hard real-time requirements provided you didn't mind crashing if the system couldn't garbage collect fast enough. And that really wasn't an adequate solution to the problem. So that was the best I knew.
Crashing or just running out of memory?
Tell me what the difference is.
You proceed, but you maybe missed your hard requirement.
No. I mean, you run out of memory, and it cannot finish the collection because it didn't do it in time, and there was not enough memory left to finish, and it really is you. Right? So you got your hard real time at the expense of every once in a while the whole thing just stops dead. Was not a good trade-off. But absolutely clear, that's a good open research area, and if there's a solution to that, we would love to hear about it. But that's not one of the ones we are pursuing right now. Questions? So let me just wrap up by saying I do believe we would like to schedule the one on security, and I do believe we would like to schedule the one on feedback. My instinct is to say let's do the feedback one first. I know that sounds silly, but the window of opportunity is closing fast, and rather than delay longer, I think that might be good, and then we can do another feedback on the security story. But I would love to hear what you think. And as I said at the outset, if we want to do that kind of feedback thing, I have to ask the research guys, get together, decide that it's worth doing, and do it as an organizational issue so that we can come back, have a coherent story from across research, at least from Redmond. UK is welcome too, but that may be a lot to ask of you here. And then we will put aside the time we need to listen to you carefully and work with you on addressing some of the issues. But you do need to do the homework to pick out the ones that are globally important and prioritize them in some way for us and give us a good picture of why it's important, what needs to be done, whether the problem is known and how hard you believe it to be. And I really would like to see that. So thank you very much.